All right, this is a good method to solve grade 6 geometry, standard 3, drawing polygons on a Cartesian plane and then finding the distance of the lengths. Now, this is the traditional way and this is the real life way. This is a better real life model. What you want to do is you want to get a map of your city. Okay, mine's is Las Vegas, right? And Las Vegas, fits perfectly nice in a Cartesian grid. You want to get whatever city you are in, okay? And you might want to give each student a copy of the city. I'm just using this on the board as one general idea, but you can give it to the students individually. And instead of them having to solve triangles or quadrilaterals or pentagons on a Cartesian grid, it's good to get them a map and then list important parts of the city and then have them find the distance of that. So for example, okay, so we have a Cartesian grid here, right? And let's say, because the students know the city really well. So I want to start with the most important part of Las Vegas, the Las Vegas Strip. Let's say you ask the student, okay, let's find a coordinate of the Las Vegas Strip from the most southern part to the most northern part. So the southern part of the Las Vegas Strip will be located at 1, 2, so -1, -2, and -7. So they can label -2 and -7. Okay? And the most northern part of the Las Vegas Strip is located at 1 and -2. So they could just locate that. Then, we do want to find polygons, right? So you want to give them another important part of the city. So let's say something like, let's say the North Las Vegas Airport. I know it's quite a way, but for example, let's just use the North Las Vegas Airport. So a student would say the North Las Vegas Airport's at 5. So, sorry, we gotta go this way. Sorry about that. -6 and 5. So you put a tag there. Then you have a triangle they could draw. They could draw in a triangle, right? And then using the distance formula, they could find the distance of each side, right? Now, because this is the student city, you could do this many different ways, and depending on how you group the students, they can have different results. So let's use another example. Instead of the Las Vegas Strip, let's try since students really like going to the malls, let's try the malls in this city. Okay, so there's 3 major malls on here. Okay, the first major mall is the Premium Outlets. Now, if you're from Las Vegas, you would know the Premium Outlets, and the students would. That's located at -1 and 2. So -1 and -2. Let's say another famous mall is Meadows Mall. Okay, Meadows Mall is located over here. General -7 and 0. So we'll put a nice little tag at -7 and 0. Another famous mall is the Fashion Show Mall, which is the one on the strip. So a lot of students would know that. So that's -3 and -8. And let's go for one more mall. Let's go for, it's a pretty far one. Oh, it's not on here. Sorry, I was looking for the one in Anderson. Well, let's go with the Boulevard Mall then. That's close to the strip. So let's go with the Boulevard Mall. And that's located at 3 and -8. So now, we have 4 malls located, right? Now the students can identify what quadrilateral it is. So they can identify that it is, well, it's actually like a skew quadrilateral. So we have one side here, one side there, one side there, and another side there. So we have kind of like a skew quadrilateral. And again, using these coordinates, students can find the length of them, right? The distance formula. So this is kind of like a real world representation of finding polygons on a Cartesian grid. It's better executed when each student has their individual own. So this is a nice representation on how to do that activity.